Okay, hi everybody. So this is 10-6, and there's a few theorems. They're not the easiest, but I'm going to go over all of them with you. So when two chords intersect in the interior of a circle, so if you have a circle and we have just two chords that intersect randomly, it's divided into two segments that are called segments of the chord. So whenever they refer to segments of the chord, we're talking about like that piece, okay? We have actually four segments of the chords. So just a FYI. Okay, so the first theorem, I wrote it out for you, is 10.18. It's called segments of chords theorem. Just want to point out, this means this is the 18th circle theorem. So like I've said, there's a lot of theorems. So it says, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So I want you to remember what product means in math. Okay? So I'm just going to take this piece, for example, first. So it's saying EA times EB is equal to EC times ED. That's what that theorem is saying. Okay? And since it doesn't matter which one you multiply first. So that's that. So let's try an example here. This is saying solve for x. So according to segments of chords theorem, I'm going to do 2 times x plus 1 equals 3 times 4, which is 12. And then I'm just going to solve for x. And hopefully you get x is 5. Okay, so that's the first theorem for the day. Okay, so this one's not a theorem, it's just like an FYI. So looking at the picture, we already know what a tangent is. So in this case, this is called a tangent segment. So instead of a line, it's just a segment. It still intersects at the one point S. They're also going to talk about secant segments and external segments. So I guess just so you know, PR is a secant segment. So I know secants are lines, but for these theorems, they're going to call them secant segments. You don't necessarily need to understand that, as long as you understand these two theorems. They can be tricky. They're hard to memorize. Okay, so 1019 is called segments of secants theorem. So yes, even though these are segments, they're secants, right? Because they kind of intersect the circle at 2 points. Normally it would be a line. It's just a segment. So what it says is if two secant segments share the same endpoint, so that's E, outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So you probably are like, what does that mean? I know. Okay, so this is what it means. Let's take EA. You have to multiply that by the whole segment EB. So you take the external piece times the whole thing, and that's going to equal my second external piece, which is EC, times, again, the whole thing ED. So it's not terrible. I know the wording sounds terrible, but if I explain it like that, it makes more sense. So again, let's go over this. The outside little piece times the whole secant segment is equal to the, again, the external piece times the whole thing. So let's take that theorem and apply it here. So how would we find x here? So since we have two secant segments that intersect at the outside of a circle, which is R. So we're going to take 3, and I'm going to multiply it by the whole segment, which is 3 plus 9 is 12. And then I'm going to multiply it by 4. And then the whole thing, right, is 4 plus x, or x plus 4. And then there we have it. Now, like, just solve, like a normal equation. Feel free to pause this if you want to check your work. So when you do solve for x by yourself, you should get x is 5. Okay? Alright, last theorem for the day is called the segments of secants and tangents theorem. So here's the main difference. We have a secant segment, but we also have a tangent here. That's the difference between these theorems. Whereas up here, we have pretty much two secant segments. Okay, you can read this whole theorem to yourself, but just to save you time, you're going to take the tangent piece, which is EA here, and you're going to square it. Okay, so this tangent squared is equivalent to my other external piece, which is EC, times the whole segment secant, which is ED. That is what all those words are saying. So again, you take the tangent piece, you square it, and you set it equal to EC times the whole segment secant. Okay? All right, let's now apply that. So you should notice this is my tangent piece, so that's what I'm squaring. So x squared is equal to, what do you think? See if you guys can do this without me. So you should have done 1 times 4, right? So x squared is equal to the little piece outside, 1, times the whole segment secant, which is 3 plus 1. So if x squared equals 4, how do we get x alone? We take the square root of 4. So x should equal 2 here. Okay, and that's it. So glue this foldable in, and then you can start your classwork.